our third example is, it is a partial fraction decomposition containing an irreducible quadratic factor. So find the partial fraction decomposition of 4x squared minus x squared plus 15x minus 29 over 2x squared minus x squared plus 8x minus 4. So based on the given rational expression that we had, so is the rational expression of the uh, denominator and then the numerator fit in the guideline that we had discussed a while ago? So let's check by inspection. So the degree of the numerator is 3, and then the degree of the denominator also, it is 3. So therefore we cannot start on partial fraction decomposition. So what we need to do is we need to solve first. We need to use the long division method so that we can arrive with the expression in which the numerator is less than the degree of the numerator is less than the degree of the denominator. So using the long method, so just apply the long method, the long division method. So we can, so if we divide 4x squared minus this one by the denominator, our quotient will be 2 plus the remainder x squared minus x minus 21 over 2x squared minus x squared plus 8x minus 4. So this is the our division. So next step is, so what we need now is to so next step is we need to find the factored form of for our denominator, 2x cubed minus x squared plus 8x minus 4. So here is the next step. So we need to find the factored form for this one. So 2x squared minus x squared plus 8 minus 4. So the factored form for this one is the denominator may be factored by groupings. So as follows. So we have here x squared times 2x minus 1 plus 4 times 2x minus 1. So this is an special technique. So after that is so this is the one of the method in order for to find the factored form for such functions. So and then so 2x minus 1, 2x minus 1, so just copy and then focus in here. So x squared plus 4. So here it is. So for example, if by grouping, so factored by grouping, so if you have 2x times x plus 1 plus 4 x plus 1. So sorry for everything. So x plus 1. So all I need to do is just copy the x plus 1. So to find the factored form, x plus 1 times 2x plus 4. 2x plus 4. So that's how the concept for this solution or method was applied. Okay, so next step, so we already have the factored form for our denominator. So now is the time to multiply. Let's multiply. So at this point, we are going to apply only or to use the partial fraction decomposition of these rational expressions. So just neglect first the 2. So next step, so we know, so again we had already the factored form for our denominator, 2x cubed minus x squared plus 8x minus 4. So next step, the same step is we need to multiply this one to each side. So if we multiply this factored form into the left side, so 2x cubed minus x squared plus 8x minus 4 will be cancelled out because they are just equal. So this is the factored form, so this is the expanded form, so they are just equal. So this is x minus, so the remaining would be, so x squared, so the remaining would be x squared minus x minus 21. So again, so let's multiply. Let's multiply the x squared plus 4 times 2x minus 1 in here. So what we will be arriving is we have uh, ax plus b 2x minus 1. So the x squared plus 4 will be cancelled out. So in the last term is, if we multiply the factor form of the denominator in the last term, is the 2x minus 1 will be cancelled, and then the x squared plus 4 will remain. So this is the result. So next step is, again, is we need to expand them. So expand, so using distributive properties, so 2ax squared, so negative ax, so b times 2x is 2bx, so b times negative 1 is negative b, so c times x squared is cx squared, plus 4 times c. So this is our next step. So the last step would be, we need to group all the variables, or to group them with the same terms, in the same terms. So in terms of x squared, so we have 2a plus c. So we group 2a squared plus c. So here it is. So next step is, in terms of x, group the x, so negative a and then positive 2b. So this is the groupings for in terms of x. So in terms of constant, so we have negative b plus c. So this is already our constant. So after that is, if you arrive already in this one, or the groups for the coefficients for each terms. So I mean, with respect to terms, so we need now to equate the coefficients for. So the first one is for the highest degree, which is x squared. In terms of x squared, so we need to equate the coefficient for all the coefficients with x squared. So this is one. So first one. So let's try first for the left side. So x squared, we have coefficient 1. So this is already 1. In the right side, just copy 2a plus c. And then next step is negative, for in terms of x, so in the left side is, we have negative 1, and then negative a plus 2b. So here it is. So in terms of constant, so we have negative b plus 4c in the right side, and then we have negative 21 here. So again, the equal remains, so they remains, and it serves as the division, or it's like a barrier for the right side and the left side. So in order for you to solve it easily, so what you need to do is group them or write them in a column, so with the same A's and then B's and then C's, so that after, so when you try to solve for them, so using elimination or substitution, so you can already identify them easily. So based on the equations that we had, so just try to use all the methods that you had. So if you're going to use the elimination, substitution, so anything you want, so that's your homework. So we could, so the final answer, so what we could get here is that our a is it will be equal to 3, then b will be equal to 1, and c will be equal to negative 5. So at this point we need to substitute. So here is our so ax plus b over x squared plus 4 plus c over 2x minus 1. So before I forgot, so in this kind of example that we had, x squared minus a, so this is the combination of, so this is a distinct root, and then this is I mean, this is a distinct linear factor, and this is a quadratic linear factor. So again, this is a combination of a distinct linear factor and then a distinct quadratic factor. So this is our final answer. So just substitute. A is 3, b is 1, c is negative 5. So just substitute our values in here Therefore, our final answer is 3x plus 1 over x squared plus 4, which is this one is under the uh, uh, distinct quadratic factors. So, and then plus negative 5 over 2x minus 1. So this is under the distinct linear factors. So our last example is it is a partial fraction decomposition containing a repeated quadratic factors. So we need to find the partial fraction decomposition of 5x raised to 3 minus 3x squared plus 7x minus 3. So based on the problem, we we don't need to find the factor from already because it is already stated or uh, in the equation. So it is already given. So the factor form is already given. So uh, what we need to do is to convert them into the form for the partial fraction decomposition. So again, so x squared plus 1, this is not factorable, so we can say that this is under the quadratic factor, since so it is under the repeated quadratic factors rather. So let's try the what you call this in the concept that we had discussed earlier, that so ax plus b over x squared plus 1, so this is under the repeated quadratic factors, plus cx plus d over x squared plus 1 squared. So again, so let's try some example. So if we have, so assuming that if our denominator is this is equal to x squared plus 1 raised to 3, so assuming, so all you need to do is so the same with your first term, so ax plus b x over x squared plus 1. So okay, so next one is cx plus d over x squared plus 1 over raised to 2. So take note that assuming that we had raised to 3 or cube, so uh, last step for here is we need to add plus ex plus f over x squared plus 1 raised to 3. So again, so assuming if we have x squared plus 1 raised to 3, so assuming if our denominator is x squared plus 1 raised to 3, so the same here, start with here ax plus bx over x squared plus 1 plus cx plus d over x squared plus 1 squared plus ex plus f over x squared plus 1 raised to 3. So if we have x squared plus 1 raised to 4 here, so you add here uh, gx plus h over x plus 1 x squared plus 1 raised to 4. So that's how you are going to apply the concept for the repeated factors. So next step is we need to multiply the factored form or our denominator to both sides. So x squared plus 4 will be cancelled out, and then the ax plus b, so there will be a remaining x squared plus 1, and then in the last term, if we apply this one in here, so cx plus d is the x squared plus 1 squared will be cancelled, so the remaining would be only cx plus d. So after that, we need to expand them, so let's use the distributive property. So ax times x squared is ax cubed, ax times 1 is this plus okay, so b times x squared, so this is b squared, so ax times 1, this is a, so b, so this is already in the last step, so that's okay. So just simplify them, so follow these steps that we had discussed earlier. So after that, we arrive with this final step. So overall, we have ax squared plus bx squared plus a plus cx plus b plus d. So we already, so this is this step we're in the groupings for with the same term. So next step is now we are going to equate the coefficients for, so for x raised to 3, so in the left side we have 5 here, left side. So equals, in the right side we have a. So this is already the value for a. So for in terms of x squared, so we have -3, and then b. So this is already our value for b. So in terms of x, we have 7 in the left side. 7, a plus c. Yeah. So in terms of a constant, so we have -3 in the left side equals b plus d. So again, so our a is already we already solved for the value of a and b. So a is 5, b is -3. So just substitute a in here. So you could get the value for c, and then the b in here. So d will be, you will get the value of d. So overall, the value for a is 5, the value for b is -3, and then the value for our c is the value for our c is positive 2, and then our d is equal to 0. So just take note with the answer. So again, our d is, so overall if you simplify them, so our d is equal to 0. So this is our final answer. So therefore the final decomposition for this kind of problem is this term is equal to 5x minus 3 over x squared plus 1 plus 2x over x squared plus 1 raised to 2 or squared. So that's all. Thank you for watching.